Hey class! Today we're going to do the little last bit of section 2.4 that we didn't hit on the last lesson. Again, we are in the section titled Chemical versus Physical Changes. Now, one thing to talk about when we talk about chemical and physical changes is this idea of the conservation of mass. And our key question here is, how are the mass of the reactants and the mass of the products of a chemical reaction related? So let's recall what a chemical reaction looks like. Remember, a chemical reaction usually has their reactants on the left, and then we have an arrow showing that a change has taken place, and then we're going to have the products on the right. Just as a general reminder, reactants is what you start with. Products are going to be what you end with. Here it says during any chemical reaction, the mass of the products is going to always be equal to the mass of the reactants. So that means if we have my reactants and I started with 50 grams, that means my products also must be 50 grams. You can even have it in a way in which you have, let's say, 10 grams plus another reactant that's 10 grams, plus another reactant that's 30 grams, and then this still equal 50 grams. Again, they still equal the same amount. Let's do an example that we used when we talked about chemical changes. When wood burns, substances in the wood combine with oxygen from the air. So we know that we have those two things as reactants, wood and oxygen. As the wood burns, a sizable amount of matter is actually reduced to one of the products that we call ashes. And ashes is a very small amount compared to the vast amount of wood that we started with. And this reaction seems to involve a reduction in the amount of matter, which means it appears that we have less matter than what we started with. But one thing to note is that appearances can be quite deceiving. Two of the products when you burn wood is carbon dioxide gas and water vapor. So again, we have wood as a reactant plus oxygen as a reactant yields, we know we get ashes, and then here it says we have two other things. We get CO2 gas, carbon dioxide gas, and we get water vapor, or H2O, in a gas form. We usually only see ashes, which is why it looks like there's a reduction in matter. However, we also get two other things that are created, carbon dioxide and water, and both of these are gases. And gases are really hard to trap, and oftentimes we see them released into the air. So even though it looks like there's a reduction in mass because all I see is the ashes, we actually are going to have the same amount of mass when you start versus when you end. It's just the rest of the mass is in these gases, and these gases go up into the air. So when we're actually looking at the law of conservation of mass, we have to make sure that we make careful measurements because we don't want to lose any gases or anything that might form as a result. So again, careful measurements show the total mass of the reactants is going to be equal to the mass of the products. This is also true of any physical changes. So the example we just used was a chemical change, and let's look at an example of a physical change. If you had 10 grams of ice and you allowed it to melt, you should get 10 grams of water that is produced. Because again, mass doesn't change, it's conserved. And so the definition we use for the law of conservation of mass is that in any physical or chemical change, mass is conserved. Or we can say stays the same. Another way we can word that is mass is neither created nor destroyed. You can't create mass out of nothing and you can't just destroy it. It's usually going to be transferred or transformed. The law of conservation of mass is actually really easily observed when you are able to contain your products. So typically it's easier to observe when you're not making a gas. Here we have two liquids, and I actually gave these two liquids to you the other day in your chemical and physical change lab. One of these is lead nitrate and the other one is potassium iodide. Notice there are two separate reactants here. So this picture is showing the reactants. It's 43.43 grams. Notice that when we mix them, we tend to get this yellow color, and hopefully you noticed in lab the other day that yellow settles down the bottom, creates a solid, which is a precipitate. This is our products. And notice our products still say 43.43 grams. Okay. These are liquids. When they're mixed, none of these products are gases, so they're a lot easier to trap those products and demonstrate the law of conservation of mass. And that's the end of section 2.4. If you have any questions, please let me know, and I hope you guys have a great day.